Here we have a sample problem about percent ionization. If vinegar, CH3COOH, has a 1.3% ionization rate at 1/10 of a mole per liter, what will its hydronium ion concentration be? So what we have here is we have the reaction of CH3COOH with water in equilibrium to create CH3COO minus and H3O plus. We know that this reaction is happening 1.3%. So forward reactions only happening about 1.5%. We want to find out what the hydronium ion concentration would be. Now we can actually calculate this fairly easily. Hydronium ion concentration will be equal to the percentage over 100 times the initial concentration. We can plug our numbers in there. We have 1.3 out of 100 times 1/10 of a mole per liter. And that will give us 1.3 times 10 to the negative 3 moles per liter. So we could predict it will have a pH of about 3. In our samples, or second sample problem, we're asked what is the percent ionization of a 1/10 of a mole per liter solution of acid with a pH of 2.38. This one's also fairly straightforward, but we need to do some pH calculations first. So we know that we need hydronium ion concentration for this. The hydronium ion concentration will be 10 to the negative pH. Because we know pH already, we can calculate hydronium ion concentration fairly easily. I am going to figure out what this actually solves for, but one tip you can use to cut down on the amount of time it takes is you don't actually have to solve this number right here. You can actually input 10 to the negative 2.38 into the next step of the equation, and it will give you the right answer. So that is one way that you can cut down on time if you're feeling pressed for it. But we will work out what this is. This is about 4.2 times 10 to the negative 3 moles per liter. Okay. Our percent ionization is going to be equal to our hydronium ion concentration over our original acid concentration. Remember, HA is the general formula for an acid, and we're going to multiply that by 100%. So we have 4.2 times 10 to the negative 3 over 0.10 moles per liter. And multiply that by 100%. Like I was just saying, you could also simplify this a little bit by doing 10 to the power of negative 2.38 moles per liter over the initial concentration. And of course, times 100. That can save you a little bit of time if you find that you're getting crunched. This is going to give us, of course, a 4.2% ionization rate.